Today we'd like to talk about finding the lowest common multiple of two or more numbers. A multiple, remember, is always larger than the original number. So for instance, multiples of 4 would be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and we can keep working this way. All these numbers are multiples of 4. Multiples of 5 would be 5, 10, 15, 20, 25, 30, 35, and so on. The lowest common multiple is the smallest number that is shared by both. So if we look at these two lists, the smallest number that is shared by both would be 20. Now this method of finding the lowest common multiple, although it can be used all the time, can be inefficient in terms of you have to list all the numbers. But that's what a multiple is. So if we look at some other situations, we see that often we can find the lowest common multiple just by looking at the two numbers. And there's two different cases here to consider. In the first case, if both numbers are prime, then what happens is the lowest common multiple is the product of the two of them. So if we look at the number 5 and 7, both numbers are prime. So it turns out the lowest common multiple will be equal to 5 times 7, which would be 35. The second case is when the numbers aren't necessarily prime. So if we look at the second example, neither 8 nor 9 are prime, since 8 is 2 times 4 and 9 is 3 times 3. They're not prime numbers. But if we think about the factors of 8, remember 8, 2 goes into 8 4 times, but 2 goes into 4 twice, and of course 2 goes into 2 once. So if we look, the factors of 8 are 2, 2, and 2. For 9, 3 goes into 9 3 times, and of course 3 goes into 3 once. So we see that the factors of 9 are 3 times 3. So neither of the two numbers have any factors in common. So in this case, the lowest common multiple once again will be the product of these two. So it'll be 8 times 9, which is 72. Now, another case is when one of the numbers is a factor of the other. So if we look at these two numbers, 4 and 12, we know that 4 is actually a factor of 12, since 4 times 3 is equal to 12. And if this is the case, then the lowest common multiple is actually the largest number. So therefore, in this case, the lowest common multiple will equal 12. Now, when all else fails here, when it's not where one number is a factor of the other or both numbers are prime, and we don't necessarily want to list the numbers, when we get rather large numbers, like this case where we have 45 and 18, starting to multiply 45 in our head is rather difficult. So we have to come up with another way of doing this. So the way of to do this is to look at the factors of 45 and the factors of 18. So if I start with 45, 5 goes into 45 9 times. Now remember, 9 isn't prime, so we have to continue to break it down. 3 goes into 9 3 times, and 3 goes into 3 once. So the factors of 45 are 3 times 3 times 5, or we write it as 3 squared times 5. Now we do exactly the same thing with 18. 2 goes into 18 9 times, and once again 3 goes into 9 3 times, and 3 goes into 3 once. So the factors of 18 are 2 times 3 times 3, or 2 times 3 squared. Now to find the lowest common multiple, we list all the factors that are used. So if we look, 45 has a 3 and a 5 as factors. 18 is a 2 and a 3 as factors. So we need 2's, we need 3's, and we need 5's. And then for each of those, we put in the largest exponent that we need to make up either one of the two factors. So if I look here, we see that 3 is raised to the power of 2 in both cases. So we're going to need 3 squared. If I look, 5 only appears once, so I only need 5 once. And an 18, 2 appears once, so I only need 2 once there. So the lowest common multiple then will be the product of all these. So if I multiply this out, I'll have 2 times 3 times 3 times 5. And I do a little multiplication trick. 2 times 5 is 10. And 3 times 3 is 9. So the lowest common multiple will be 90. Let's try one more. If we look at these two numbers, 56 and 20, once again, neither of those are prime. 20 isn't a multiple of 56, or 20 is not a factor of 56. So we will use factorization to find the lowest common multiple. So with 56, 56 is a rather large number, but I know since it ends in a 6, 2 is going to go in there. And if I do that division, we have to do that off to the side. 2 goes into 56 how many times? Well, 2 goes into 6. Well, 2 goes into 5 twice, leaving me a 4 there with 1 left over, and 2 goes into 16 8 times with nothing left over. So that'll leave me 28, and once again 2 goes into 28, leaving me with 14, which 2 goes in again, which leaves me with 7, which is prime. So my factors are 2 times 2 times 2 times 7, or 2 cubed times 7. If I look at 20, once again it ends in a 0, so 2 goes in there 10 times. And once again it ends in a 0, so 2 goes in there 5 times. And 5 is prime, so it's 5 times 1. So the factors of 20 are 2 times 2 times 5, are 2 squared times 5. So now I'm ready to find my lowest common multiple. And if I look, both contain a 2. 57 contains a 7 as a factor, and 20 contains a 5. And now I need the largest power that is contained in either the first number or the second, or if there were 3, the third number. So if I look at the first one, 56, it's 2 to the third power. This is 2 squared, so I take the larger of those two, 2 cubed. 7 just appears once, so I just keep it 7 to the first, and 5 appears once, so it's 5 to the first. So multiplying that out, again I have 2 times 2 times 2 times 7 times 5, so I'm going to do this little trick again. 2 times 2 is 4, times 2 times 5 is 10, times 7. So again I'm going to do 4 times 7 is 28 times 10, which is 280. So that's how I'm going to find my lowest common multiple using factorization.